Okay, so let's do this question. So I won't bother reading this, but basically what the question is we have a table which assigns a number to a combination of fundamental force and property, and we have to write the correct number attributed towards the gauge boson here. So we have four gauge bosons here, and we have to determine for each of these gauge bosons what is the correct combination of fundamental force and property attributed towards that gauge boson. And each of these combinations have a number. So let's get started. Gluons. Gluons are responsible for strong nuclear force. Now, let's say I have three quarks here, an up quark, an up quark, and a down quark. Right? Really, really basically, what is it that holds these quarks together to make a proton? Well, it's a strong force, right? And the strong force which holds these quarks together is mediated or carried by gluons, right? So gluons are the force carriers for strong nuclear force, right? And another thing to note about gluons is gluons have no mass. They are massless, right? So we can immediately answer the first part of this question. The answer for here for gluon is 1, right? Because gluons have mediate strong nuclear force, and they are massless. So 1. Okay, photon. Now, straight away, I think most people will know that photons are massless, right? Photons are massless. Okay, well, what force do photons mediate at a subatomic level? So just keep in mind, we are concerned with a subatomic level here. And at the subatomic level, photons actually mediate electromagnetic force. Now, if you think about a photon, it's a combination of an electric wave and a magnetic wave, like this, right? So a photon carries electromagnetic force, right? It's basically a fluctuation in an electromagnetic field. So if you have an electromagnetic field and you create any disturbance in it, you will create this wave here, this oscillation, right? Which is a photon, a mix of a electric and magnetic wave, right? And that's a photon. So photons carry electromagnetic force. They mediate electromagnetic force, and they are massless. So straight away, we can answer this question. This part of this question. So photons are massless, and they mediate the electromagnetic force. So the answer to this is 5. Right. Okay. So W and Z bosons. W and Z bosons mediate the weak nuclear force. Now, the weak nuclear force plays a role, very simply put, in certain types of radioactive decay, specifically beta decay, right? So that's the role of the W and Z bosons. Now, W and Z bosons are very different to the ones we've seen, the gauge bosons we've seen so far, in the sense that W and Z bosons do have mass, right? So just remember this: W and Z bosons actually have mass, right? Even though they mediate force, right? They carry force and communicate force to different particles. They themselves also have mass, right? So W and Z bosons have a mass and they mediate weak nuclear force. In other words, our answer is this, right? Number 4. Okay, so number 4. And same thing with the W boson. Our answer is number 4, right? Okay. Which of the fundamental forces below has the longest range of interaction? Now, mind the wording here, range, right? Range. We are not talking about strength. We are talking about range, not strength, right? And range does not equal strength. So there's a difference, and we have to keep that in mind. Now, in terms of range for these three forces, and actually I'll include gravity as well. Gravity, which is the fourth fundamental force, right? We have 3 here. The fourth one is gravity, which is not written here, but I'll just add it in anyways. Gravity and electromagnetic force are basically unconfined, which means their range is infinite. Gravity and electromagnetic force can act between particles that are an infinite distance apart, right? And you might have heard this law, which is called the inverse square law. And what that means is Well, I just write it down. Uh, oops. Very, very roughly, strength. The strength of an electromagnetic force or the gravitational force between two objects is proportional to 1 over the distance between those two objects squared. Now, why does it say r, right, instead of d? R here stands for radius. And the idea behind that is if you have a point here and a point here, or if I have this same point here, but another point here, right? So let's call this A, and I have B here, and I have C here. Well, if you actually think about it, the distance between A and B here, let's say, is 4 meters, is the same here, right? It's just in a different direction, but the distance between A and C is also 4 meters. So for both of these, even though they're in different locations, the distance between them from A is the same. And a way to model this is a sphere, which goes like this. And the radius of that sphere is the distance. So if I have I'll just draw this better. A sphere like this. So the further I am from the sphere, I can be in any location, but there is a fixed radius which is describes the distance I actually am from A. So I can also be here, I can be here, or I can be here, but as long as I'm in this sphere or on the skin, the circumference, right, of the circle or the edge of the sphere, I'm the same distance away from A, right? So the radius is the same. Let's say I'm 5 meters, then we'll define a new bigger sphere, right? For everything that fits in that range. So that's what we mean with the r there. So 1 over r squared basically means 1 over the distance between the two objects squared, right? And if you look at this equation, this correlation, right, we can see that as r gets bigger, this value that 1 over r squared is equal to gets much smaller. But does it ever get to 0? Well, no. As you can see, if I just make r bigger, the number will keep getting smaller, but it will never equal 0. It will get closer and closer to 0, but it will never equal 0. Unless I have, of course, 1 over infinity squared, right? Then, if this is a limit, then I have a 0. But infinity is very different. Infinity is not a number in the normal sense. So just ignoring that, we should very clearly see that as r increases, it never turns to 0. This equation will never turn to 0, or this correlation will never turn to 0. And what this means is electromagnetic force and gravitational force have infinite range. And if you think about the Earth and the Sun, how far away are the Earth and the Sun from each other? Yet they still exert a force on each other. Now, what it actually means is if the Earth and the Sun were on opposite sides of the universe, they will still exert a force on each other, right? You can have an infinite distance between them, any number from 0 to infinity between them, and there will still be a force, a gravitational or electromagnetic force between them. They can be, right? And it will never equal 0. Obviously, if you're on opposite sides of the universe, it will be very close to 0, but it will never be 0. Unlike weak nuclear and strong nuclear force, which, as we say, are confined, have a confined range, which means there is a point where, for our purposes, there is some radius r, let's say r prime, right, where the strength equals 0 for our purposes, right? So weak nuclear and strong nuclear have a certain distance or a certain radius where the effect of the force is now 0. In other words, they have a confined range, which means, going back to the question, which of the fundamental forces below has the longest range of interaction? Well, it will be the electromagnetic force, because the electromagnetic force has infinite range, right? So the answer is II, electromagnetic force, right? And okay, let's do a bit of background. This is not 100% useful and it's not graded, but I just want to explain why the W and Z bosons have mass and why gluons and photons do not have mass. Okay, so this is a Higgs field. Now, the idea here is that everything, so electromagnetic field, gravitational field, everything is a field. right? Or it has a corresponding field, and all these fields exist on top of each other and in the same space. So this is a 2D representation, but you can also have a 3D representation where it also goes up like this, right? You can have something like that, and the idea is all these fields exist in the same space and they all interact with each other. Now, what's special about the Higgs field? The Higgs field is responsible for mass, right? So, which is a very strange concept because you think of mass as something solid, but the concept here is actually that mass is just a fluctuation in this field. So let's say I have a random bump like this. I have my field, and in my field is a bump right here. Right? So what is this? Well, according to physics, this bump is mass. So everything that has mass only has mass, or you're only detecting mass because of this bump. Or in other words, when you're detecting mass, what you're actually detecting is a bump in the Higgs field, right? Okay, so why do gluons and photons not have mass? Well, they don't interact with the Higgs field. A photon in an electromagnetic field, let's say the electromagnetic field is here, right below the Higgs field, like so, right? If there's a bump in the electromagnetic field, it does not interact with the Higgs field. So the electromagnetic field oscillation, right? A bump in an electromagnetic field, which is known as a photon, will never ever obtain mass. The Higgs field does not interact with it; it ignores it. So the Higgs field does not give it mass. Now this is obviously it's a little bit more complicated, but this is a very simple explanation, just in case you're interested in why and how something can have no mass, right? Similar idea with the gluon, but when you have a W or Z boson, let's say they have their respective field, and there's a fluctuation in that field, which is what a W and Z boson is. A fluctuation in that field will in turn create a fluctuation in the Higgs field. So if you have a bump in one field, the Higgs field on top also has a bump, right? Because they interact with each other. So both uh so both W and Z bosons are given mass. They obtain mass through interacting with the Higgs field.